projects. In this video, we are going to explain about a project titled Different Stages of Heart Diseases. In this research, we conducted an extensive investigation into various stages of heart disease using a diverse set of advanced machine learning algorithms. By effectively leveraging the combined strength of these algorithms, we developed a robust and precise predictive model for categorizing the heart disease stages based on a wide range of features. The finding of this project bear significant implications for enhancing the early detection and personalized treatment approaches, thus making the notable contribution to enhancement of cardiac health and patient well-being. The main goal is to offer a detailed and all-encompassing understanding of heart disease, encompassing its different stages and related risk factors. The objective is to increase the awareness about the significance of preventive measures and the effective management through adopting the healthy lifestyle choices and medical interventions. Additionally, the aim is to stress the importance of regular medical checkups and early detection, as this can lead to better outcomes and elevate the impact of heart disease on the individuals and the society. These are the basic requirements that are needed to build this project. The software requirement: Python IDE with version of 3.7 or Anaconda with version of 3.7 or Jupyter or Google Colab. And the hardware requirements are operating system as Windows or Linux, processor of minimum Intel i3, RAM of minimum 4 GB and hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. In this, the necessary libraries are important. Commonly used libraries such as NumPy, Pandas, Matplotlib, and sklearn are typically imported. And the second one is exploring the dataset. The dataset is thoroughly examined to understand its structure, content, and potential relationship between the variables. Exploratory data analysis techniques are employed to visualize and analyze the data. And the third one is data processing. Data processing is then crucial for preparing the dataset for model training. This step involves handling the missing values, encoding the categorical variables, scaling the numerical features, and removing the irrelevant or redundant data. Proper data processing ensures that the dataset is suitable for model building and enhances the model's performance. And the fourth one is splitting the data to the train and test. The dataset is divided into the two subsets, the training set and the testing set. The training set is used to build the machine learning model, while the testing set is used to evaluate the model's performance on the unseen data. And the fifth is of building the model. Here, multiple machine learning algorithms are utilized to construct the predictive model. The first one is logistic regression. Logistic regression is used for the binary and multi-class classification task. It predicts the probability of an instance belonging to a particular class using the logistic function. The algorithm is particularly useful when the relationship between the features and the target variable is linear or close to the linear. It is relatively simple, interpretable, and computationally efficient, making it a popular choice for various classification problems. And the second one is SVM. Stands for Support Vector Mission, is a powerful algorithm that finds an optimal hyperplane to separate the data point of the different classes. It works well for both linearly separable and non-linear separable dataset. SVM aims to maximize the margin between the classes, making it robust to outliers and effective in high-dimensional spaces. SVM is widely used for binary and multi-class classification tasks and as the application in the test classification too. And the third one is KNN. Stands for K-nearest neighbor, is a non-parametric classification algorithm that classifies a data point based on the class label of its K-nearest neighbor. The algorithm measures the distance between the data point and assigns the majority clause among its K-nearest neighbor. KNN is simple initiative and dealing with the data set to handle the multi-class classification task. And the fourth one is decision tree. It's a hierarchical tree-like structure that recursively split the data based on the feature value to make the decision. At each internal node, the tree tests a specific feature and each branch represents a decision based on that feature value. Decision trees are interpretable and handle both categorical and numerical data. And the fifth one is random forest. Is an ensemble learning method that combines the multiple decision tree to make the prediction. Each tree in the forest is built on the random subset of the training data and a random subset of the features. The final prediction is determined by aggregating the individual tree predictions and random forest is effective in handling the lost data set, reducing the overfitting and providing the high accuracy and robustness. And the sixth one is MLP, stands for multi-layer perceptron. It's a type of artificial neural network including of input, hidden and output layers. Each layer consists of the interconnected neurons and each connection has of weight associated with it. And the seventh one is GNB, stands for Gaussian Naive Bayes. Is a probabilistic classification algorithm based on the Bayes theorem with naive assumption that all features are independent of each other given in the class. It assumes that the features follow the Gaussian distribution. It's simple, of computationally efficient and well suited for the test classification. And the final one is voting classifier. It is an ensemble learning method that combines the multiple individual classifiers such as logistic regression, SVM, KNN, decision tree, random forest, MLP and GNB to make the predictions. The final prediction is determined by taking the majority vote among the individual classifier for the classification task and averaging their output for the regression task. Voting classifier help to improve the model performance and reduce the risk of relying on the single classifier basis. And then sixth one is training the model. The model is trained using the training dataset, which involves learning from the input features and their corresponding target labels. The machine learning algorithm adjusts the parameters to find the best fit for the given data. And the seventh one is user give the input. Here, we are using the Flask framework employed to build the web interface, allowing the user to provide the input for the heart disease prediction. Users interact with the web application, enter the relevant information such as of age, gender, and other mode, and submit their input for the prediction. And the eighth one is the given input is pre-processed per prediction. The user's input is pre-processed to align with the format used during the model training. Data pre-processing techniques similar to those used during the dataset preparation are applied to ensure that input is in proper format for the model. And the ninth one is trained model is used for the prediction. The pre-processed input is passed to the trained machine learning model, which utilizes the patterns learned during the training to make the predictions regarding the presence and the stage of heart disease. And the final one is final outcome is displayed. The model's prediction is then presented to the user through the Flask web interface. The final outcome reveals the likelihood of stage of heart disease and including the predicted stage or severity. The project aims to provide the user with valuable insight and support for early detection and preventive measure related to the heart health. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder containing of the different files within it. The first one is dataset file and the static folder containing of the images within it, and the template folder containing of the HTML documents which are about heart disease, home and no disease HTML document. And the app is an py file likely contains the information related to the front-end logic. It could include the code written in Python that handle the server-side operations such as processing user requests, interacting with the database, and generating the dynamic content that will be rendered in the HTML template. And the IPYNB file is a Jupyter Notebook file which contains the information of the code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. To execution of the project, first we need to copy this address and open the Anaconda prompt. Here first we need to change this disk location by F because our code folder is present in F disk, and then write the command cd space and paste the address of the code folder and then click on enter button. After this we need to write another command as python space app.py. By this the command it is used to execute the Python script and perform a runtime check for any syntax errors or logical issues, and then click on it enter button. After running the python app.py, the Flask framework will host the application locally at the default address as of this. We need to copy this local link and and open the Chrome or any web browser and paste it, and that way and we get an home page like this. Here we need to enter the details of this. Enter your age, and my age is 21, and enter your gender, that is female, resting blood pressure that is of 125, and cholesterol, that is 142, and fasting blood pressure, that is of greater than 120 years, and rest ECG results are normal, and maximum heartbeat is 98, and chest pain during the exercise, no, and chest pain type, no, and then click on submit button for predicting the heart disease diagnosis. After submitting, we get an page you have been diagnosed with no disease. In this way, we can diagnose the heart disease by using the various machine learning algorithms. In conclusion, we comprehensively studied the different stages of heart disease by employing the various advanced machine learning algorithms, including of decision tree, random forest, multi-layer perceptron, Gaussian naive-Bayes, voting classifier. By harnessing the collective power of these algorithms, we successfully constructed a robust and accurate predictive model for classifying the heart disease stages based on the diverse features. This project outcomes hold the significant potential for early diagnosis and personalized treatment strategy, ultimately contributing to improved cardiac health and patient care.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.